So at the top of that notebook page, you can put that we are doing lesson 8.6 notes. We're continuing on in 8.6. So we'll call them notes 2, because we've already taken some notes in this lesson. And what's different today from the first set of notes that we took when we were solving by factoring. When we were solving by factoring earlier in lesson 8.6, a was equal to 1. So when a does not equal 1, we can still try factoring to solve it. You just have to go back and revisit how do we factor those quadratics, those trinomials, when a is not equal to 1. So we'll just go right to practicing because there really is not anything new to learn today. We're going to factor it, and we're going to set each factor equal to 0, and we will have our solutions after we solve those factors for x. Okay, so number 1, we're going to solve 3x squared minus 4x plus 1 equals 0. So remember, our first goal always is to make sure that we have the set equal to 0. In other words, 0's on one side, standard form's on the other side. And then we can identify our A, B, and C, because we're going to need all 3 of them today, not just our B and C. Okay?
I think I know how to do this.
Okay, so let's first identify our A, B, and C, and then you'll get us started, Jossie. What's A equal to? 3. B equals? Negative 4. And C equals?
1.
Okay. And take the time to write those down because, again, there's going to be that one extra step today that you do not have to do when A is equal to 1. So, Jossie, what do you think we do in these?
Don't you multiply the A and the C?
Yeah, we still use our diamond, don't we? We start out with our diamond.
And then you put the 3 on top.
And we put our B down here. Okay, so we have 3 times 1, which is 3. And we have our B down here, which is negative 4.
Oh, just kidding.
Negative 3.
So we need to find what multiplies to be a positive 3, but yet they're going to add up to a negative 4.
Negative 3, negative.
Yeah, so we're going to have to make our 3 and our 1 both negative, because a negative times a negative is a positive, but yet they will add up to our negative 4 like we did here. Now here's where it goes different. Be careful here. We don't stop here now and say, okay, our factors are x minus 3 and x minus 1. We have to, remember what these do is these now rename the middle term. They take this right here and they replace that. So remember, these become negative 3x plus negative 1x. So we can't go right to setting up our factors because our A is not equal to 1. This is the one where we rename the middle term and we end up with a 4-term polynomial for a while. And what do we do when we factor a 4-term polynomial? Factor by grouping. So we're going to take our quadratic trinomial. It was 3x squared, but instead of minus 4x, we're going to put plus negative 3x plus negative 1x. So the negative 3x plus the negative 1x is replacing that minus 4x. And then it's plus 1, am I right?
Yes.
Okay. So we just renamed our quadratic. It's no longer a quadratic trinomial, it is now a 4-term quadratic instead. And now we'll do our factoring by grouping. We'll let this be our first group. This will be our second group. When we factor by grouping, we GCF each group, independent of the other. So what's the GCF of the first group?
3x.
3x. And what's the resulting factor?
X plus negative 1.
Plus x plus negative 1. Negative 3x divided by 3x is -1 plus. What's going to be the GCF of our second variable? We want it to be -1, don't we? Because we want, when we divide, we want that to be a positive x, so it matches our other one. So we factor out a -1 instead of a +1, and we end up with x plus -1 that way. Because remember, the goal is, when we factor by grouping, we need a matching factor. And we now have that. Okay. So now let's rename this quadratic as what we just did right here. We have the one that they have in common. That's one of our factors. What's the other factor?
3x minus 1.
3x plus -1 or 3x minus 1. Okay, so here's our extra step today that we have to do because our a wasn't equal to 1. Now we're going to do just like we did the other day. Set each of our factors equal to 0 and solve them. So we have our first factor of x plus -1. We'll set that equal to 0. And 3x plus -1 will be set equal to 0. It is not uncommon when a is not equal to 1 that the solutions will end up being fractions. That's not uncommon. That can happen very easily. Okay, so what do we have to do to solve this first one? Add 1 to both sides, and our solution is x equals 1. There's one of our solutions.
And then you would add 1 to both sides.
Add 1 to both sides of this one also.
And you get 3x.
You get 3x equals 1, right?
3.
What's our next move now?
Divided by 3.
Divide both sides by 3.
1/3.
And we end up with, as I said, it's gonna be a possibility that yes, you will get fraction solutions today. X equals 1/3. We have two solutions. X equals 1, x equals 1/3. Would this be a good one, do you think, to solve by graphing?
No.
Can you tell me why?
Just a fraction. Because I don't like fractions.
Well, not because we don't like fractions, but because would we be able to tell with this one, especially this solution, x equals 1/3, would we be able to tell that it's crossing the x-axis at exactly 1/3?
No.
Probably not. So this, when a is not equal to 1 and we end up with fraction answers like this, it's typical that the graphing method is going to be would not be a good way to solve it. That's why we have the algebraic way to solve it also. Okay, good news, I'm not going to make you do check problems today. So you get to skip those. We'll do one more practice if you don't have any questions on this one. And then you can go to work. You only have 5 problems to do. No concerns on this one? Okay, then let's do a second one. Number 2, here's our quadratic. Is it set equal to 0?
No.
We had add 9 x squared.
And let me just throw out to you right now, it does not matter which side 0's on, but here's what you do want to do, and this will make life easier for you. Just trust me on it. Always try to make your a value a positive number. It just works better, okay? So whatever way, don't think of it this way. I only want to move one thing. Don't have that mindset. Let your mindset be this instead. What do I have to do so that I will have a positive a value? So by moving this 9x squared over, that would make it a positive 9, our positive a value would be a positive 9, and that would be, it's going to be friendlier that way. So we're going to let this side be our 0 this time, and in standard form, the 9x squared would come first, followed by the 30x, followed by the 25. So again, if it means moving 2 things, move 2 things. Have a positive a value. It's actually better to work with it that way. So now we will identify our A, our B, and our C. A is 9, C, B is 30, and C is 25. We have some big numbers to work with this time, aren't we? Okay, so remember we set up our diamond. A times C is up here, our B value is down here. So A times C, 9 times 25. 225. 225. Has to add up to 30. Here's the thought process you always want to have when you have a big number up there. Isn't it a perfect square? Okay, what times it's 15? So 15 times 15 is 225.
15.
And 15 plus 15 is 30. So typically, when you have a big number up there, typically what will be friendly and happen is that that's going to be a perfect square. And you're going to be able to do just like we just did very easily here. Okay? So what does this tell us again? What is this?
That's a middle term.
Yeah, these become 15x plus 15x, don't they? That's what that tells us.
They are. Never mind, just keep going.
Okay?
Because I'm not the other part.
You're the other part already, okay. So, remember, we're gonna rewrite our quadratic, replacing that 30x with our 15x plus 15x. It's gonna become a 4-term quadratic now instead of just a trinomial. And we're going to do our factoring by grouping. So, what's the GCF of the first group? 3x. 3 is the largest number that divides out of 9 and 15, and then x.
You get 3x plus 5.
So 3x plus 5.
Oh, whoa. Okay, I see what I did wrong.
What's the GCF of the
3,
next group?
or no, 5.
5, okay. And what will be the result?
3x plus 5.
3x plus 5. Okay. So, first thing is that in common, they have this factor right here. This is the one they have in common, first of all. So, the one they have in common,
Then 3x plus 5.
and then the other one comes from, okay, we got a 3x that we GCF'd out, plus a 5 that we GCF'd out. So it just so turns out that both of the factors are the same.
So you have to do it once.
You only have to do it once, don't you? Remember, when the factors end up the same, we only have to set one of them equal to 0 to solve it. So 3x plus 5 gets set equal to 0. What's our first move? Subtract 5 from both sides. And now we have 3x left alone, and what's on the other side?
Negative 5.
Negative 5.
And you divide both sides by 3.
And now we're going to divide both sides by 3.
Then you get x over negative 5, 3, or you can.
So x equals a negative 5/3 because 3 doesn't go into it nicely.
Or you get negative 1 and 2/3.
Yeah, or we can say that is negative 1 and 2/3. Just the same answer. We only have one solution. We only have one solution. It's just that it can be renamed as negative 1 and 2/3. In other words, so we would know where it would touch or cross the x-axis. When there's only one solution, let's be reminded. What does that tell us about the graph?
It only touches the x-axis.
It only touches the x-axis once. Well, it only touches the x-axis once. What's that mean?
Vertex.
It's its vertex. The vertex is sitting there at that spot on the graph.